Okay, so in this problem, 132 kilovolt system is given. The reactance up to the location of circuit breaker is 3 ohms, and capacitance up to the location of circuit breaker is 0.015 microfarad. We have to calculate the frequency of the transient oscillations, maximum value of the restriking voltage across the contacts of the circuit breaker, and maximum value of rate of rise of restriking voltage. So frequency of transient oscillation is what? Fn is equal to 1 by 2 pi root LC. Maximum value of restriking voltage is equal to 2 into Vmax. Maximum value of rate of rise of restriking voltage is omega n into Vmax, where omega n is 2 pi f n into Vmax. So reactance is given here. So you know reactance XL is equal to 2 pi FL. You can determine the inductance value XL by 2 pi F. Okay, from this formula. XL is 3 by 2 pi F according to Indian standards frequency, even though it is not given in problem, according to Indian standards, F is equal to 50 hertz. So 3 by 2 pi F into 50, you will get 0.00954 Henry. Okay. If you complete, inform me. You just type C. Type C if you completed. If you have completed, type C. So from the given data, we have determined the inductance value. Okay, completed? Okay. Okay then. So let us just determine the frequency of transient oscillations. Okay, so you already know the formula. Fn is equal to 1 by 2 pi root LC. C value is given in the problem. What is C value? 0.015 microfarad. L value just now you have determined, that is 0.00954 Henry. So substitute L and C in this formula. Substitute L value and C value in this formula. You will get 1 by 2 pi root of 0.00954 into 0.015 into 10 power minus 6. You just divide it. Divide all this whole expression with 1. You will get 13.291 kilohertz. Okay. Now the system voltage is given, that is 132 kilovolts. Where is it? Yeah, it is 132 kilovolts. So it is the line to line voltage. You can determine line to neutral voltage from this line to line voltage. So line to neutral voltage is line to line voltage by root 3. So line to line voltage is given what, that is 132. So 132 by root 3 will give you the line to neutral voltage. Okay. So if I want to determine the maximum value, Vmax, so root 2 into VLN, line to neutral voltage, will give me the Vmax value. So you know VL line to neutral voltage is 132 by root 3. So root 2 into 132 by root 3. You can simplify it. I have not simplified. I have left it as it is. Okay, you can solve it using the calculator, and you can write down the numerical value, whatever comes, whatever you get in your calculator. Okay, so you have got some expression or some Vmax value, that is root 2 into 132 by root 3. So maximum value of restriking voltage formula you already know, across the circuit breaker contacts is given by 2 Vmax. 2 into what is Vmax value? Root 2 into 132 by root 3. Okay, now you can at a time, I have simplified at a time. Yeah, so you just simplify it. You will get 215.56 kilovolts. Okay. So we have written kilovolts. Why? Because this line to line voltage is given in kilovolts. Okay, so yeah, you have got an expression for restriking voltage. I'm sorry, you have got an value for restriking voltage, that is 215.56 kilovolts. If you complete this slide, inform me. So in your problem, they have asked you to determine the frequency of transient oscillations. Okay, so we have determined frequency of transient oscillations, that is 13.295 kilohertz, and they have also asked to determine the maximum value of restriking voltage across the contacts, that is 2 Vmax. We have got 215.56 kilovolts. Next, leftover is rate of rise of restriking voltage maximum value. If you know the formula, no need to wait for me. You people go on solving and type the answers in the chat box. If you are able to solve, don't wait. You solve on your own. Okay, completed. Very good. Next, we have to determine the maximum value of rate of rise of restriking voltage. Okay, so the formula is omega n into Vmax, and omega n is what? 2 pi Fn. Okay, you know Fn value, just now you have calculated, substitute Fn value into Vmax is 132 by root 3 into root 2 kilovolts. Instead of writing I have included this kilo here. That's why I have multiplied 132 into 1000 by root 3 into root 2. Okay, I hope you have understood. Okay, substitute Fn value and Vmax you already know. So Vmax value I have considered in volts instead of kilovolts. Okay, so K I have included here. I have multiplied 132 with K. Okay, so you just simplify it, you will get 9010.45 into 10 power 6, and I have multiplied with 1000, so that I have got 9.01045 kilovolts per microsecond is my maximum value of rate of rise of restriking voltage. If you complete, inform. Okay. Okay, then let us go to the next problem. Okay, in this problem, a 50 hertz generator means the the frequency of the EMF is 50 hertz. Has this generator has EMF to neutral 75 kilovolts RMS value is given. Okay, line to neutral voltage is given here. That's all I think. Okay, and the reactance of the generator and the connected system is 4 ohms, and the distributed capacitance to neutral is 0.01 microfarad with resistance negligible. Okay, so you have to determine the maximum voltage across the circuit breaker contacts, frequency of oscillations, rate of rise of average up to rate of rise of restriking voltage average value up to first peak of the oscillations. Okay, so in this problem you need not worry about the frequency. Frequency value is already given in the question itself, and even if it is not given, you can determine it. Okay, line to neutral voltage is given, that is 75 kilovolts, and the reactance of the generator is given, that is 4 ohms, and distributed capacitance to neutral is given. Okay. You have to solve it. You people try to solve it on your own because it is similar to your previous problem. You people try to solve on your own. Okay, so one slight modification. This is 7.6. I'm sorry, 7.5. 7.5 kilovolts. It is not 75. It is 7.5 kilovolts. All of you change it in your notes. It is 7.5 kilovolts. It doesn't matter whether it is 75 or 7.5. You people are going to solve it at anyway. Okay. It is 7.5 kilovolts. You just make a modification in your notes. Put point in between the 7 and 5 in your notes. Okay, similar to your previous problem, here also, since reactance is given, say you know XL is equal to 2 pi FL. Okay, L is equal to XL by 2 pi F. XL value is given, that is 4, and F is also given, of course, here. So you just solve this 4 by 2 pi into 50, you will get 0.0127 hertz. Okay, if you complete, inform me. Don't rely on me, you people solve on your own. Already we have solved one problem. Similar method, nothing new. Completed? Very good. Okay, so line to neutral voltage is given, that is 7.5. You can determine the maximum value, maximum voltage, that is root 2 into line to neutral voltage. So root 2 into 7.5 kilovolts, you will get 10.606 kilovolts. Okay, V max value, maximum voltage value you have got now. Okay, so you know voltage that appears across the circuit breaker contacts as soon as arc is extinguished is nothing but a restriking voltage. Okay, it's nothing but restriking voltage. So maximum value of voltage across the contacts. Maximum value of voltage across the contacts is nothing but 2V max. Maximum value of restriking voltage is the maximum value of voltage across the contacts of the circuit breaker. Okay, so that is 2V max. 2 into V max, you already know 10.606 kilovolts. So just multiply it, you will get 21.212 kilovolts. So maximum value of voltage across the circuit breaker, or I can say maximum value of restriking voltage. So frequency of transient oscillations is asked in the problem. So frequency of transient oscillations is Fn is equal to 1 by 2 pi root LC. Okay. So 1 by 2 pi root L value is 0.0127 into C is given in the problem, that is, what is it? What is this next problem? Yeah, that is the problem. Yeah, C value is, that is 0.01 microfarad. Okay. 0.01 microfarad. So I have written 0.01 into 10 power minus 6. Okay, so 1 by 2 pi root of 0.01 27 into 0.01 into 10 power minus 6. You just solve it using your calculator. You will get 14.1227 kilohertz. Okay, so we have determined the maximum value of voltage across the circuit breaker contacts, and we have determined the frequency of transient oscillations. Only left over is the average value of rate of rise of striking voltage up to the first peak of the transient oscillation. Okay, so if you complete, inform me. Completed. Okay then. So I will check your notebooks today after this class. Okay? I'm going to check your notebooks today. While taking attendance. So average value of rate of rise of free striking voltage up to first peak of transient oscillations is given by, it's nothing but the maximum value of the voltage across the contacts, that is 2V max, by time to reach the first peak of oscillation, that is pi root LC. Okay, so 2V max by pi root LC. Already we have calculated this 2V max. Okay, already we have calculated this 2V max value, that is 21.212. Okay, divided by pi into root LC. You know L value, that is 0.0127 into C value is 0.01 into 10 power 3. Okay. Is it 10 power 3 C value? It is minus 6. 10 power minus 6, isn't it? It is in micro farad. Minus 6. Okay. So the problem is, I usually, once I write a equation, second time I won't write again and again. I will be copying and pasting from previous problems. That's why this sort of mistakes occur. It's okay. Okay, not to type the formulas again and again, it's wastage of time. Completed? Okay. So you have got the average value of rate of rise of free striking voltage as 0.599 kilovolts per microsecond. Okay, let us go to the next problem. So next problem is, in a short circuit test on a circuit breaker, the following readings were obtained on single frequency transient. Okay. So the time to reach the peak restriking voltage of 40 microseconds and the peak restriking voltage of 100 microseconds. Okay. You have to determine its average rate of rise of restriking voltage and frequency of oscillations. So frequency of oscillations means 1 by 2 pi root LC, and average rate of rise of restriking voltage is 2V max by Tm. Okay, so the average rate of rise of free striking voltage is 2V max by Tm. Okay, so 2V max value is given. Okay, so 2V max value is given, that is peak restriking voltage of 100 kilovolts. Okay, peak restriking voltage, peak means maximum value of restriking voltage. Okay, so that is 2V max value, that is 100 kilovolts. So 100 into 10 power 3 divided by the time to reach the peak restriking voltage is 40 microseconds is given. Means time to reach the peak restriking voltage is 40 is given. So directly you can substitute here in the formula. 2V max by Tm is given. 2V max value is 100 into 10 power 3 and T max is 40. Okay. So you will get 2500 volts per microsecond. Okay. And frequency of transient oscillations 1 by 2 pi root LC. So pi root LC is what? Pi root LC is T max. Okay, it is the time to reach the peak restriking voltage. Okay, see, this problem is very small problem, but if you are able to carefully read the question, then only you will be able to solve it. Okay. So 1/2 into T max is 12 kilohertz you will get. Okay, it's a very simple problem. Okay, so simply directly they have given a short circuit test is conducted on the circuit breaker. The following readings are obtained on single frequency transient. Okay, they have given time to reach the peak restriking voltage, that is T max value, and peak restriking voltage, that is V max value. T max and V max are given. If you know T max and V max, you can easily determine the rate of rise of restriking voltage average value and frequency of transient oscillations. Okay, so the problem is, this is a very simple and easy problem. If you complete, inform me. As soon as you complete, just inform. Completed. Let us solve one more problem.
మ్యామ్ ఇంకా కంప్లీట్ కాలేదు మ్యామ్.
కాలేదా? ఎవరో పెట్టారు కదా అయిపోయిందని, అందుకనే మార్చాను. ఓకే ఓకే, నో ప్రాబ్లం. This class is being recorded, so if you want to talk to me, you talk in English. Otherwise, you text a message. Okay, Nama? All of you. If you want to talk to me, you just talk in English because it is being recorded and it will be uploaded. You can text a message if you want me to wait, if you have not completed. See, this problem is very simple and completed. Are you the person who spoke to me just now, Sandeep? Yes. Type YMA if you have spoken to me just now. Okay. So I wanted to make sure it's you or not. Okay. Okay, I'm wearing this slide. Okay. So next problem. It is similar to your first problem, it seems. In a system of 132 kilovolts, the circuit phase to ground capacitance is given. Okay, that is 0.02 microfarad. Inductance is 5 Henry. Okay, the circuit breaker interrupts a magnetic circuit of 5 amperes. Means it is interrupting a magnetic circuit of 5 amperes means it is interrupting the magnetizing current. Means it may be an reactor or a unloaded transformer winding which this circuit breaker is interrupting. Means it is interrupting low inductive current. So this 5 amperes is low inductive current. So you already know whenever a circuit breaker is interrupting low inductive current, current chopping occurs. Okay, you have to calculate the voltage across the circuit breaker contacts after current interruption. Okay, and you have to calculate the value of resistor to be used across the contacts to suppress restriking voltage. See, you know, whenever circuit breaker is about to open an low inductive currents, what will happen? Current chopping occurs. Means current will be interrupted within the loop instead of at natural current 0 point. Okay, so in order to avoid chopping, because of chopping transients occur in the circuit across the circuit breaker contacts. So in order to avoid chopping, a series resistance, a resistance is connected across the circuit breaker contacts. Okay, so we have to determine the value of the resistance that is to be connected across the circuit breaker contacts. Okay, and you have to determine the voltage across the circuit breaker contacts after current interruption. Okay, so in the given data, line to line voltage is given, capacitance and inductance value is given. So the voltage that appears across the circuit breaker contacts is the prospective voltage, isn't it? As soon as current chopping occurs, okay, as soon as current chopping occurs, the voltage that appears across the circuit breaker contacts is prospective voltage. So for this problem especially, if you know the concept, then only you will be knowing the formula to use. So you must get the idea V is equal to I into root of L by C formula you must use. How will you get the idea? If you read the question carefully. Okay. So circuit breaker is interrupting magnetizing circuit of 5 amperes. As soon as I read it, immediately I told you that it is a low inductive current. So whenever circuit breaker is interrupting low inductive current, that means it is current chopping will definitely occur across the circuit breaker contacts. Okay, means the arc will be interrupted before its natural current zero. So you definitely need resistance switching to overcome this. Okay. So the voltage that appears across the circuit breaker contacts after current interruption of 5 amperes, V is equal to I into root of L by C. That is the prospective voltage. Prospective voltage V is equal to I root L by C. So I is 5. Okay. L value is also 5. C value is 0.02 into 10 power minus 6. Okay. You simplify this, you will get 79000 V, that is 79 kilo ohms. Okay, the voltage that appears across the circuit breaker contacts is 79 kilo volts. That is the prospective voltage. If you complete type C, if you have not completed type NC. If you have not completed type NC, yeah, okay. Those who have typed NC, type later on C. I am remembering your roll number. I have seen your roll number. Type C later on. Those who have not completed. Okay. So for this subject specially, someone has typed NC. They have not completed. Let me check. Roll number. Yeah, your roll number 219. Yeah. Okay. So for this subject, Amma, if problems are given in the exam, you must first of all read. If those problems are very direct problems, then it is okay. It's of no, okay, it's not an headache. But if these sort of problems are given, you must read the question carefully. You must try to understand it, and you must know what sort of equations that you must use. Okay, so we have calculated the voltage that will appear across the circuit breaker contacts when the circuit breaker is interrupting low inductive currents. Now, the value of the resistance to be used across the contacts of the to suppress the restriking voltage. Resistance formula you already know. R is greater than or equal to 1 by 2 root L by C, if you remember. Greater than or equal to. So let us assume it is equal to 1 by 2 root L by C. You know L value, C value. So the R value is around 7.9 kilo ohms. The resistance which is to be connected across the circuit breaker contacts to suppress or to not to allow the restriking voltage to appear across the contacts, to suppress the restriking voltage. If you complete, inform.